Hey y'all, what's up? I know we just had a New Orleans lunch, but you know, no nap times. It's learning time. So I first came to Elixir, perhaps like some of you, via Ruby, as Brian just said in the intro. Ruby was something that I came to after a lot of other languages that perhaps should remain nameless, but Ruby was a good foundation for us. And then I really came to Elixir because I was interested in the beam. I had started learning about the beam and how amazing the virtual machine is. And then I sort of couldn't jive with the syntax of Erlang. It was really tough for me to take pleasure in day to day. So when I found Elixir, it was sort of a breath of fresh air. The syntax is great. The core concepts are really, really wonderful. And so I just kind of fell in love with it. And so like any developer, that is exploring a new language, I picked it up and I built a thing with it and built an app. And then, you know, at that point, it's like, well, what now? What's next? Well, I got to deploy this thing somehow. So this talk is mostly about deploying. There's almost no Elixir in it, and I'm sorry for that. I didn't mean to hook you into something you weren't expecting. My name's Logan Leger. I run a company called New Aperio. We're a web and mobile development shop here, actually here in Louisiana. For those of you that are not local, we're based in Baton Rouge, which is the capital city just down the interstate from New Orleans. For the past several years, historically, we have been a Ruby shop, but this year we have made the transition, and 100% of our projects are now written in Elixir on the website. And it's been a really wonderful transition, and we're really excited about it. As part of that transition, I've spent most of this last year running DevOps, getting up to speed on what it takes to run Elixir in the cloud and deploy it. And so this talk is a culmination of everything that I've learned over the past year. So when you deploy a new language, you kind of start out like with what you know. You start out with your roots, right? And so coming from Ruby, my roots were in Capistrano and Heroku. I mean, Capistrano was like the thing we did way back in the day. And it was an okay tool, but it was kind of brittle. It didn't really scale very well. All it did was like open SSH sessions to your boxes and run commands directly on them. At some point, we got sort of this revolution in Heroku, and for us, it was a game changer because it allowed us to stop spending a ton of time on DevOps and just kind of deploy. I mean, I'm sure a lot of you are familiar with Heroku. It's as simple as a git push, and that was a really nice transition. A lot of our projects are greenfield approaches, and so we can, instead of focusing on the DevOps, we were able to focus on the features, which is great. So whenever I came to Elixir, I started with Heroku. I mean, that's what I knew. That's where we came from. And so I had this app, and I deployed it. I deployed it to Heroku, and you know, it was fine. It worked fine. It ran, and actually, you know, it was kind of a validation for me when I first started writing Elixir, because you go to the Phoenix website, and you know, like one of the guides under deployment, it's like the very first one. At the time, I think it was the only one, and it's about deploying to Heroku. But as we started building like more sophisticated apps, whenever we started breaking out just out of the Phoenix CRUD app, and we started building stuff that was using gin servers and taking more advantage of the VM, we realized that Heroku's Dino model, which is their web process model, just did not jive at all with the Elixir model, with the Erlang VM model. One of the things that Heroku does is that every day their dynos restart. It's kind of like it happens in 24 hours. You can't really tell when it's going to happen. At just some point, they're going to get restarted, which if you have a gin server and you're storing state in that gin server, that's terrible, because then all of a sudden all of your information is gone. Supposedly, if you're using it for like maybe a cache or something that's not expensive to hydrate, you could get away with it. But if you're storing something mission critical, it's just not going to work. The other thing about dynos is that they're firewall from each other. So if you really wanted to do the distributed clustering and stuff inside of Erlang, you can't do that at all on a Heroku system. So coming away from Heroku, we tried to find what we thought might be the next best thing, and we stumbled across Gig Elixir, which some of you might have familiarity with as well. It's kind of like where Heroku was 6 or 7 years ago. It's like Heroku built explicitly for Elixir. And so the problems that I just described with Heroku, they actually solve. And it's nice to just have a quick deployment environment to just do a git push and get something up there. But it feels like it's just not quite there yet. It's a little rough around the edges, a little untested. And for some of our heavier, more production grade services, we just didn't totally feel comfortable leaving it there. So that really brought us to AWS. And AWS is where we ended up. This talk is going to be sort of specific to AWS, but some of the general concepts will apply to other environments as well. So what does it take to deploy to AWS? It really takes three things. First, you need a container, a Docker container, which is going to contain your application and all of its dependencies. You also need an orchestrator. And the orchestrator is going to take the container and it's going to run it on the cloud infrastructure resources. And then the last thing that you need is a provisioner. The provisioner is going to take the container and provide it to the orchestrator and run it on some underlying resources. So it'll build out the networking, the firewall rules, it'll build out the databases, it'll build out the underlying server instances themselves. You need these three portions of it. So let's talk about a container. First of all, let's dive into what a container is. I think for some people, I know for myself when I was first coming to it, you kind of look at containers and they kind of talk like a container, they kind of walk like a container. I'm sorry, they talk like a VM and they walk like a VM, and so you think they must be a VM. You know, they're similar to a virtual machine. It's not, but they're not at all. If we look at a VM, the VM is going to have your application and its dependencies. But because it's a full-blown virtual machine, underneath that, it also has an entire operating system. So it's this giant stack that sits on a host machine and gets managed by a hypervisor in order to gain access to the shared resources on that host. A container, meanwhile, is a little bit more optimized. It doesn't have that full operating system underneath it. And instead, containers run natively on the kernel. So they're just part of the kernel, and all it has is your app and its dependencies. And it has direct access to the resources that are on the underlying host system. So containers are, one of the things that I kind of like to think about containers is, and this is not an exact simile, but if you think about containers are to virtual machines what OS threads are to Elixir processes. You can run way more containers on a host than you can VMs because containers are way more lightweight. One of the other things I want to cover, because this was a source of confusion for myself personally when I started working with Docker, is a lot of times you'll see the word images and containers used sort of interchangeably. So the image is actually the base thing that gets built by Docker. And whenever you run an image, it turns into a container. So the container is basically has the runtime state, and that's what turns it into a container. This might be sort of heretical to say at a functional programming conference, but for those of us with an OO background, you can sort of think of your image as your class, and you can think of the container as an instantiation of that class. So whenever we talk about containers, like a lot of the other communities out there have like fully embraced containers. And I've heard, it took me, myself, a long time to get around to containers, but now that I understand them and use them, I understand their benefits behind them. I've heard a lot of people in the Elixir community who are anti-containers, and so I think maybe if we just kind of like walk through this together, maybe we'll all love containers as much as everybody else. So there's a lot of technical benefits that we're going to go over, but one of the main benefits that I think you shouldn't be overlooked is about the actual engineering process underlying building products. Because whenever you ship a container, you ship an accessible development environment to everybody on your team. There's none of this like process of going through bootstrapping the development environment. And you don't have to have everybody on your team have the same level of expertise in running an Elixir app. Like for example, if you have a front-end developer who's just working in JavaScript, you can ship a container to them so that they can access the development environment without actually having to have expertise in setting up Elixir on their machine or running Elixir in the background. The other thing that I think is really great is that it removes the whole like works on my machine paradox. So like you ship a container, because it's containers are portable, you're shipping the same container wherever you build it, wherever you ship it, it's the same thing. That gives you the confidence to know that that stuff is going to work. The other thing that it's really great for is because it's portable, you have this seamless transition from CI to CD, because you can build a container in CI, you can push it up to production in CD, because again, it's portable. You can build it anywhere and deploy it everywhere. There's some other benefits as well. I should mention the security benefit, because containers are isolated, are sandboxed, so your processes are isolated, and that's really nice. I should also mention modularity. If there's anybody in here who's using microservices in their stack, you'll gain a lot of benefits out of building using containers, and it also works with umbrellas, which is fantastic. So when we talk about containerizing Elixir, there's two things we should know. Compared to an interpreted language, because Elixir is compiled, you can actually use what's called a multi-stage build. And so basically you have a primary container that sets up the build environment, and you add all the dependencies that are necessary to actually build the binary, and then you build a binary and you export it. And so your containers are way, way smaller. It's much easier to build an optimized small container inside of Docker using Elixir than it is with a lot of other languages. The other thing that I should mention is that without some extra work, because containers are sandboxed, you're not going to be able to do the process communication in the Erlang VM. So you won't be able to do the distributed or clustered part of Elixir just straight out of the box. It's possible. It takes just a little bit of extra work. So I'm actually going to take you through. I have a Docker file that I built. I just want to walk through the architecture and some of the best practices of it whenever we're talking about Elixir. So this is interesting. So I can't actually see it on my screen. Oh, well. All right, so the first thing that you have to know is in the side of a Docker, whenever Docker actually builds the image, each line inside the Docker file runs in what's called a separate layer. And this is part of Docker's caching system. And one of the things that is important to know is that you want to try to minimize the number of steps that you run, because that'll actually make your Docker container more optimized. It also makes it a lot faster. So whenever you look inside of Docker file, you'll see these run commands, and then you'll see like a bunch of commands that are chained on together, and it looks really wonky, and probably if you were writing a script, you wouldn't write it that way, but it actually creates a more optimized Docker image. The other thing about the caching system that's important to know is that because it caches from top to bottom, you kind of want to put things that are least likely to change at the top and things that are most likely to change at the bottom, so that you take advantage of the maximum amount of caching possible. The other thing that we talked about was the multi-stage container build. And so you can see I have from at the top. This is just pulling a base image. The Alpine variants are always going to be the smallest variants. This is just the official Docker Elixir container that comes off of the Docker registry. And so we add the necessary ingredients in order to run like Mix, and you got to install Yarn and Node in order to run your Webpack. One of the things that's important here is, and this is like a really micro optimization, but it's kind of cool, is whenever you run these APK commands, which is the Alpine package manager, if you run -- no cache at the end, it won't save any index of the package manager, and that just contributes to like smaller images overall. So this first image runs through, and it actually creates this sample app that we have right here is called Revista. It runs a distillery release, and it exports it puts it in a specific place, and it just exports the tar. And this second container that we have down here, what it actually does is it pulls the release out of the primary container. It sets up what is necessary for that container to actually run the binary, which is really just the OpenSSL dependency. And we add bash in there just so we can like log in and mess with it. And then at the bottom, the command, this is actually what it runs. Whenever you run Docker command without giving it any additional command line parameters, so by default, it's just going to run the Elixir release. So that's the Docker file. The Docker file again is kind of like your blueprint for your image. So some mouse over here. I don't know where the mouse is. There it is. Okay. All right, so that's our container. There's two more portions that we need. The next one is the orchestrator. So now that we have this container, how do we actually run this in the cloud? In order to do that, you need an orchestrator. And I kind of like to think of orchestrators, and this is really apt considering that we're in a concert hall, but orchestrators are kind of like the conductor of a symphony. So your orchestrator is going to take the container, and it's going to place it on the server instances that you tell it to run them on, and it's going to run these processes and make sure that they're healthy. If it's a long-running process, you tell it that it needs to stay online. It's going to continue to check on it, make sure it's healthy, kill it off if it needs to be replaced, boot another one up. So orchestrators are really like the conductor that keeps everything running like a well-oiled machine. So in terms of like the orchestrators that are out there, there are a few of them. Docker Swarm is kind of Docker's native solution. It comes bundled if you install Docker on your laptop in their development environment, so you're going to have it right away. It's fairly straightforward. It doesn't have a ton. Doesn't have a ton of features. It really just has what you need out of the box to kind of get started very quickly. There's no first-class support for Docker Swarm on the infrastructure providers, so that's something to keep in mind. It also, Docker Swarm has kind of fallen out of favor in the community for some of the other options out there. One of the big options is Kubernetes, sometimes called K8. This is Google's solution. It's very, very advanced. It has a lot of features. Whenever I first got started running DevOps, I found it a little bit unapproachable at first because there's just a lot of like features that make it like super advanced. The good thing about it is it has a ton of community support. The community around it is blowing up, and it's quickly becoming a very popular solution. And it also has first-class support. So if you wanted to run a managed version of Kubernetes on whether it's AWS or Google or Azure, they all have a version of it. There's some proprietary options as well. Amazon has one that's called ECS. It's a very popular one. The agent, the code behind ECS is actually open source, but you can only run it on their infrastructure. It's only designed to run on their infrastructure. There are also some serverless options. So if you just want to give your infrastructure provider a container and you don't really care about the underlying instances at all, if you don't care about the servers or any of the resources, you can ship a container. AWS has one called Fargate, which is completely an indecipherable name to me, but it's called Fargate. And there's also Azure container instances if you are in Azure's cloud. So I think really what it comes down to is what you need. Kubernetes is a great solution, particularly if you're going with a microservices route or if you want to do some of the distributed clustered Elixir stuff because it has a service mesh, so you can do the service discovery. But in general, I think it's just kind of, if you're just getting started, I find ECS a really easy place to get started. So let's talk about ECS. We're gonna use it. I'm gonna show a demo of the code and what that looks like. I used ECS when I got started because I found it really simple to understand, but also I was like already in AWS's world. So if I say like acronyms like IAM and VPC and ALB and RDS and your eyes don't glaze over, then this is probably a good option for you to start with. If you like the AWS way of doing things, you're going to like ECS. If you don't like their way of doing things, you're probably not inside of AWS anyway, but you're definitely not going to like ECS. It's also tightly integrated into all of AWS's products. So you get CloudWatch for logging, you get ASGs for the auto scaling inside the cluster. So it's kind of it's a great place to get started. One of the things that I found sort of complicated or difficult to understand when I first got started was the operating model, so the process model, how ECS sort of models everything inside of it. So I thought it would be good to run through that and sort of talk about it. The base unit inside of ECS is called a task. And you define these in JSON using what they call task definitions. And the task is really like you give it a container, and you can override some of the aspects of the container, and then you tell it like what command you want to run. This is where you do the injection of your environment variables if you need to do any runtime configuration. There's two types of tasks. There's a long-running task. Like for example, if you have a Phoenix web app, that's a long-running task. You're going to have a migration that's going to be a one-off task. Doesn't matter, they're all tasks. On top of the tasks, you have what are called services. And services are really like the scheduler portion of the overall orchestrator, because what the service is going to do is you tell it which tasks you want to be long-running and how many of them that you want to be running. And it'll make sure that those tasks stay alive, and it'll make sure that those tasks keep running. So it's just kind of the thing that sits on top of tasks. It's important to know that you will have some things inside of a service, like your web server, and some things outside of it, like your migration or your one-off tasks. All of these are run, of course, on top of EC2 instances, which is just AWS's computing servers. So the service itself is going to schedule the tasks onto instances. You can run tasks, like one-off tasks, directly on the instances. And all of this kind of gets buttoned up together inside of a cluster. And one of the things that sort of tripped me out when I first started working with ECS is that there's like no direct connection between an EC2 instance and an ECS cluster. So you create a cluster, and really all you do is give it a name. So you're like, web production is my cluster name. What you then have to do is you have to make sure that the EC2 instances you want to be part of the cluster have Docker installed. And then you need to make sure that they have the ECS agent installed, which itself is just a Docker container. So all you have to do is do a Docker pull to get that installed. And then you have to place a file at etc ecs/ecs.config, and just put a variable in there called ecs_cluster and the name of the ECS cluster. And then whenever that instance boots online, the agent runs, it looks at that config, and then it adds it to the cluster. So it's kind of a little bit of magic there. To sort of tie all this together as an example, what you might have in a world like this is a cluster that you call like web production. And you might have a service inside of that called web, which just runs your web server. And then you'll probably have a task called web, and then you might have a task called migrate or a task called seed. So that's kind of how these things tie together. So just as a quick demo, I was going to pull up the AWS console just to kind of show how they map everything. I find their console sometimes can be a little bit tricky to understand. But inside of here, what you have is you have these clusters. So inside of this AWS account we have for this little app that we set up. Of course, I don't have Wi-Fi, so this is going to be difficult to show. Well, anyway, what you would see here is you would see the list of your services. So this is inside of your main cluster. You would have a list of your services, and it's going to show you how many of the tasks are running. Because typically, you're going to have some sort of scaling involved in the number of tasks that you want to run in order to accept your load. And that's itself is going to be part of some auto scaling. So it's going to tell you which ones, how many of each of these tasks are running, and whether or not they're healthy. All right, so we've got a container. We have an orchestrator. So now we need a provisioner. And so a provisioner is like, how do you actually create the resources that underlie all of this, right? You've got these things that are inside of AWS's console. You've got these EC2 instances. You've got this ECS cluster and all of the stuff that goes along with that, the networking, the databases, et cetera. How do you provision all that, tie it together so that it's really easy to provision these things? There's a couple of different options. AWS has a native one called CloudFormation. I find CloudFormation really difficult to use. The syntax is just a mess, and it also sort of locks you into AWS. I don't know that whether or not vendor lock-in is something that you should actually be concerned about, but in this case, CloudFormation is going to lock you in. You won't be able to port your infrastructure anywhere at all. There's a couple of other tools that you might have heard of. Chef, Puppet, Ansible. These are all sort of in the configuration management side. You might currently use these if you're provisioning boxes by themselves. Inside of a containerized world, you don't really need them because what you're shipping are images that have all of the dependencies that the container needs to run. So you don't really need to do a lot of the configuration side of stuff that these tools provide. So what we ended up using was a product called Terraform. It's a HashiCorp product. And really, if you take nothing else away from this talk, I just want you to take away that Terraform is amazing, and all of you should be using it. Terraform is basically, you give it configuration files, and what that does is it allows you to turn your infrastructure into code. And so the configuration language is very easy to pick up. It's JSON compliant. It doesn't look exactly like JSON, but it's close enough that all of you, I assume, have worked with JSON. You're going to be able to pick it up very quickly. It creates this infrastructure as code. So you check it into your code repository, and that way you can do pull request reviews on the changes in your infrastructure. You can have CI actually run the changes to your infrastructure and report back what those changes looked like. One of the big things that Terraform is a proponent of is called immutable infrastructure. So basically, whenever you're making changes, you're not necessarily like logging into the same server and making changes on that exact same server, because what that can create is like these subtle bugs in your infrastructure where some of your server instances might be a little bit ahead or have different versions of dependencies. It just tears things down and it rebuilds them. Whenever you use Terraform, it creates sort of like this internal map in memory of the current state of your infrastructure, and then it creates a map based on the configuration that you have, and it compares those two, and it actually does a diff of those two. So it knows what changes it needs to make on the AWS API in order to bring your infrastructure up to what your configuration files actually say. It's a really great tool. There's a ton of benefits to using it. I think the idea of seeing your infrastructure laid plain in configuration files that are easy to understand is really great. And then also having the ability to push all of your infrastructure through a CI/CD platform is also great. There's all of these other layers to it that also make the infrastructure changes way more error-free. It's a declarative language, and that really helps you do some cool stuff. So I'm going to run through some Terraform files to kind of illustrate this. So inside of this repo that we have, there's an infrastructure folder. And this infrastructure folder is broken down into a couple of different sections. You've got your global, these are going to be resources inside of AWS that have no environment. You think about like your DNS, your routing, any of your identity management. All of that stuff is not tied to a single environment, and so you put it inside of global. Then you've got production or prod. You would also consider having other environments there alongside of them. Like right here, all we have is prod, but if we wanted to set up a staging environment, we would just duplicate this folder, maybe change some of the variables in terms of like how many servers we want to boot up, and then we could have an exact replica of our entire production infrastructure in staging. Inside of that folder, you have a couple of other folders. Your VPC folder is going to be all of your networking stuff. So this is creating the VPC in AWS land is the virtual private cloud. So it's just it's a software networking layer inside their data center to hold all your resources. That's where you set up like your like firewalls and things of that nature. You then have data storage, which in the case of a web app, you're going to have like a Postgres database. So that's going to be your RDS setup. This app in particular is an umbrella app, and so under data storage, we actually have multiple databases because the umbrella is running multiple databases. Under services, this is going to be the services that you run inside of this environment, whether that's a web app, it could be a GraphQL API, it could be an admin backend, however it makes sense to split up your services. This is where they go. Inside of these folders, you have three separate, and you're going to see a lot of this. This is sort of the best practice in Terraform land. This main is going to be where you define all of your resources, and so you can kind of see that the syntax is very JSON reminiscent. You've got your resource that you create, and in this case, this resource that we have right here is the task definition on ECS. And we load this from a JSON file. So we just have a JSON file where we provide it with the environment variables, we provide it with the commands that it needs to run, and whenever we run Terraform, it actually runs this, it runs through this and pulls the JSON and pushes that up. And you can see we've got our service which connects, it runs, it makes a reference here to that task definition, to that web task definition that we just created above. And then you'll have your, there's some other services in here, and then you've also got this user data, which is the one, this is what I spoke of earlier. The user data just runs whenever AWS boots up a server for the first time, and this is just doing that, so it's tying the cluster, this instance to the particular cluster. Whenever, I'm going to show you an example of actually running this. I'm not, I'll show you the output of running it. So this is really, I guess, let me blow this up for you guys. So this is a run. This is Terraform run. So there's two commands that are prevalent in Terraform. One is plan. So what plan is going to do is it's going to download your current infrastructure, compare it to the configuration files, and it's just going to tell you what the differences are. There's some key things that are happening here. One, Terraform understands what resources actually need to be changed and what changes can be applied in place, for example. And then it's also going to understand which ones need to be torn down and recreated. It also understands dependencies. So if you change something that is connected to other things, it understands those connections and will actually propagate the changes across all of those separate resources. If you've ever used the AWS console, you understand how beneficial this is, because AWS's console is really, really cryptic and it's hard to understand, particularly if you have things that are cross-referenced to each other. So this is just downloading all of the state for these are all of the resources that are inside of making this web cluster run. And then what we ended up changing here are two key things. One of them is that we made a change in the environment variable that we had inside of the task definition, right? And so this is the web task definition. It's running the Phoenix web server. And so Terraform understands that the only way to create new task definitions is to create new ones. You have to delete the old one. So it's going to do that. And then it also understands that these services that we have, which run the task, the web task, are going to also need to be updated because we just created a new web task definition. And then you can also see that we made a change in here to update our number of tasks that we want to run inside of our service. So whenever you run this, right here. So this is the apply step. So after you've run the plan and you say this looks good to me, and the plan again can be run on CI. So if you open a pull request on your repo, you can have your CI run Terraform plan and report back the results. And then if it looks good, then you just run the Terraform apply step. Terraform apply step shows you the same thing. It asks for this confirmation, and then you can see it actually does the work. Destroys that old task definition, creates a new one, and then it's going to go through and update all of the other stuff. So that's Terraform in a nutshell. Like I said, if you take nothing else away from my talk today, I hope you take away the fact that Terraform is amazing and that you should all be using it. Just run back to your offices on Monday morning and tell them, we're going to start using Terraform. It's this great new tool I just learned about. All of this code that I showed today is available on GitHub. We deployed this app. It's Elixir in the .cloud, of course, which is the name of the talk. And it's all available on GitHub. So you can go here. This is an example of not only, it's sort of a reference app that we have of an umbrella app. It's sort of a contrived example, but it shows how to set up umbrella apps. It also has all the Terraform configuration, not just for the web portion, but also setting up the VPC and setting up the database and everything else. So it's a good reference for that. And it also has the Docker file so that you can read through the Docker file and sort of understand how that's built. Thank you. Can you hear me? You good?
Okay, yeah. Thank you, Logan. Does anybody have any questions? Oh, okay.
Yeah, so when you're orchestrating those containers and passing config to them, you mentioned that they're receiving their config from environment variables. What kind of stack are you using to propagate that to the Elixir as part of the stack?
Okay, so there's a couple of interesting things here. So this app is actually using Distillery 2.0, and Distillery 2.0's configuration story is way better. It's amazing. It actually works super well. Okay, and basically what you do is you just provide that runtime configuration. So there are some things that you say, like system.getinf. Like for example, the database URL is a system.getinf call, and that pulls from the environment variable that you specify inside of ECS. And so that happens at runtime. One of the interesting bugs that we actually had with this, and I think it's a good story to talk about because sometimes you forget about compilation stuff, right? Module attributes in Elixir are actually compiled. And so you can't use, there's a very common pattern that I've seen in a lot of places where you create a module attribute and you do like an application.getinf and you pull something from your application configuration. Whenever you run that release inside of your Docker file, that's going to get compiled to nil. And then you're going to the cloud, buddy, and you're not having a good time. So you just got to, so all you have to do, though, it's really easy to switch. All you have to do is change that to a function. So just make sure that if there's anything that you need to get run at runtime, it actually gets run at runtime.
So I see the Terraform plan. It's nice that you can compare your infrastructure. But sometimes when you're getting started with this stuff, it's difficult and that you're understanding both the provider itself, like AWS's tools, as well as Terraform. And so you might go and experiment and get something up and running on AWS. And then after the fact, you're like, OK, great. Now I need to add some rigidity so as moving forward, I can continue to be able to do this stuff. Because personally, with our services, I love the look of Terraform, and I know its praises. But is there anything built in, like Plan, or that would go further, that would help you reverse engineer what you had working so that you can then step forward in a more appropriate way? Like
100%. And I'm actually super glad you asked this question because I lived through the same thing where I had an existing infrastructure. And most of that infrastructure was created through the AWS console. So you're going, clicking the buttons, running the wizards, like AWS has some wizards. They'll create a load balancer, do some other stuff for you. Terraform has an import function. Okay, so what you can do is you define the resource inside of your Terraform file. You leave the resource block empty. You run the Terraform import command, and you give it the ID of the resource. It actually goes and downloads that resource's information into its state file. So that in-memory map that it's creating of the infrastructure. And then what you can do is you can start looking at the docs and you say, okay, what options do I have inside Terraform? You can compare them to the state that I downloaded. And then all you have to do is run Terraform plan. And as long as it gives you no changes, then you have a Terraform plan file that's completely up to date. So it's actually, it's a really wonderful process, particularly if you are walking into a project where there's infrastructure and there's no Terraform. It's a nice thing to do because it gives you like a full audit and an understanding of where that infrastructure is. So it's a very seamless transition.
So one of the sort of hardships that I've heard from a lot of infrastructure management tools like Terraform is when you have, it's environment scaffolding, right? Like, yeah, you've got your prod environment, and that's usually going to be fairly stable, but it's all very mainline. But often, depending on how you do things, you're going to want like 10, people are going to ask for a new environment. And one of the, you mentioned if you want a dev environment or a stage environment or whatever, you copy that folder, right? Yeah. But that's not quite so sustainable when you start talking about a bunch of environments and all the things that you need to, if you change things in prod, you may or may not want to also change that in like the other 10 environments you have. Yeah. So I'm wondering how Terraform can help with sort of templating an environment like that and just making 10 of these, but slightly different. That sort of thing. Terraform, because the people who are at HashiCorp are geniuses that love us. They provided us with a wonderful tool called modules. And modules basically allow you to dry up your Terraform code.
because you'll create a module, like for example, you can create a module called VPC, which is just all of your networking stuff. And then you can provide variables inside of that module. So like for example, if you, like in your production environment, you know, you're going to want all that stuff firewall, no public access, you're not going to want anybody to touch it. So you can have a variable in there that's just called, you know, like lockdown or whatever. And then based on that variable, you can, in like a development environment, like if you just want to spin up like a pull request environment, for example, that's going to be thrown away in a couple of hours, you don't want that stuff locked down so that you can like jump in, like mess with it and start debug it or whatever. Based on that variable, you can turn some of those rules, some of those resources on and off inside of Terraform. The Terraform language, the configuration language, is called HCL. It's currently in the first version, and then they're going to a second version. The templating stuff, the interpolation, and some of the logic that you can do in it, because it's just a declarative language, is fairly simple. But there's even more exciting stuff coming in the future. So you can do some really advanced stuff right now, but it's also about to get way better as well. So yeah, so the answer is that's possible, modules.
I had a question in regards to containers. The story behind them from a DevOps perspective, being able to ship repeatable code and all that makes a lot of sense to me. There's also, and you mentioned as well as one of the 3 points of your talk as far as like a development environment where they make a lot of sense. Personally, that's where I've had like the most pain as far as using them there. Things like changing code and having it reload and being able to like Phoenix hot reloading and stuff like that.
Yeah.
Do you have any tips or suggestions on using containers in dev and when it may or may not make sense?
Yeah, absolutely. I think that's really the pain point for a lot of people. It was a pain point for us. And what I learned was that I was just doing it wrong. And really, what you have to do is just make sure that the Docker container is set up properly, and you can do all of the hot code reloading, whether it's Phoenix or Webpack or whatever it is. Inside of a Dockerized environment, especially locally. If you're going to set this up locally, you're going to want to look into something called Docker Compose, which will actually like do the orchestration locally, so that you have like a database, and you've got like, if you have like Elasticsearch or something, it sets up those other additional dependencies locally for you. And inside of Docker Compose, what you can actually do, and sometimes it's better to actually have a Docker file that has some adjustments for your development environment that you run inside of your development environment, especially if you need a lot of that like hot code reloading stuff. So that's something that we're working on for this reference app that we have. It's not currently there, but if you want to go to GitHub and like just subscribe on it, you should be able to see something like that in the coming months.
Have you had any luck managing Kubernetes infrastructure within Terraform, whether that's using the primitives directly or through kops or EKS?
My experience with Kubernetes is mostly theoretical at this point. Kubernetes is probably like the next stage for some of our more sophisticated projects that are sort of growing outside of the ECS boundary, particularly for some of the stuff like where we're doing like microservices and stuff. And I really want to experiment with getting the service mesh stuff up and running so that we can run the distributed and the clustered Elixir. But that's very theoretical for me at this point, so I can't really talk about it. But maybe, I don't know, follow me on Twitter and maybe I'll talk about it.
All right. So at the base level, AWS, no matter what cloud you use, it's always going to scale down to your RAM and your CPUs. So how does this infrastructure, how do you do with like provisioning and accounting for how many of those you need and scaling and like working with kind of the bare metal resources on these cloud platforms? Yeah, sure. So basically, whenever you set up your tasks, you give those tasks a budget. And so you say, like, for a web service, a Phoenix web service, maybe I need 512 megs of RAM. Maybe I need like one CPU or whatever it is that you need. You set up that budget, and what you basically have to make sure is that like your default, your baseline, you get covered inside of the resources that you've deployed. But all of this is inside of AWS at least is managed by an ASG, an auto scaling group. And so as your load goes up and down, your ASG can actually read from ECS
so it understands, like where the load of the system and stuff is at, and it'll actually spin up new containers. And inside of there's one more component of that called the launch configuration. And so you tie like a launch configuration to the auto scaling group, and so whenever the auto scaling group launches a new instance, it does that based on the launch configuration. Inside the launch configuration is where you set up like that user data thing that I showed, like where it sets up which cluster it's part of. You do all that inside the launch configuration. So whenever the ASG detects that it needs, based on the load, it needs to launch more instances, it'll just launch a new instance, and then that gets registered with the cluster, and then the cluster will start making use of it based on the scaling rules that you've defined. None of that stuff is in this code, but that's coming. So
I think you may have touched on some of this. Great talk, by the way. Thanks. So we finally are in a pretty good place with clustering in our Docker containers in production. Everything's fine. But locally, it's still a giant pain in the ass. We end up having to just kind of like manually run a few Docker containers, and then like it's unpleasant. We can't use like the nice Docker Compose scale features and things like that. So I think you mentioned that you don't have this solved a second ago, but if you do solve that, that would be fantastic.
Well, I'll let all of you guys know. Yeah, I'll be like like Noah showing up in the desert or whatever. Solved it. I don't know.
All right, everybody, give it up for Logan again.
Thank you.